Today we're going to talk about roots and zeros. We actually have talked about this already, so this should hopefully be a review. Let me just start off by reminding you the difference between factors and zeros. So what we see over here are factors, where you can multiply them out to get the original polynomial. And on this side, we have the zeros. And so to go from here to here, we're just going to take each factor and set it equal to 0, and then solve for x. So for example, I would take x plus 9, set it equal to 0, and that's going to give me x equals -9. So here's another reminder with the quadratic formula. Go ahead and write that down. And take a minute to pause the video and go ahead and type this into y1, because I want to kind of do this problem. I want you to do this problem with me as I go through. So pause, put this in for y1, and then we'll continue from there. So go ahead and graph it. Your graph should look like that. Hopefully it'll let me put it right here. And so it kind of looks just like a straight line. Remember, any real zeros that there are, we're going to see them wherever the graph crosses the x-axis. And so it looks like it's -2. I'm going to go ahead and zoom out to just kind of show you that this does take the shape of a cubic function, where it has that kind of curve right there. But another thing this shows when I zoom out is that it doesn't come back down at all. It's not going to cross the x-axis again. And so because the degree is 3, there's one real zero. I can see where it crosses the x-axis. And so that means that there's 2 imaginary zeros as well. We're going to find those in just a minute. So I wouldn't really trust a graph. I would maybe double check using the table of values. So go to second graph. And we do in fact see that when x is -2, y equals 0. And so there's a few things that I want to jot down over here. First of all, the number of zeros. So the zeros would be 3 because it's degree 3. However, the only real zero there is at -2. So we're going to use that information with synthetic division to find the remaining zeros. And so I'm going to go ahead and use that -2. And then I'm going to check to make sure every single exponent is accounted for. It is. So I'm going to go ahead and bring down the coefficients. All of you should be professional synthetic divisioners. That's now a word. And so I'm going to bring down the 1. And then multiply, add, and so on. So that we get -2 right here. Add them together. Multiply -2 times 4. Get -8. That gives us 13. Multiply -2 times 13, and that gives us -26. And that's what we want, to have a remainder of 0. And then I'm going to go ahead and put this as a polynomial. So I started with degree of 3. And so all of these become coefficients starting with x squared. So it's 1x squared plus 4x plus 13. I'm going to set that equal to 0 because I want to find the rest of the zeros. And so this is where the quadratic formula comes in. So I know that it doesn't cross the x-axis anymore, so there are going to be no more real zeros, which means this cannot be factored. And so I'm going to use the quadratic formula. So I'm going to define a, b, and c. A is 1, b is 4, c is 13. And you just saw the quadratic formula on the other page. Go ahead and refer back to that if you need to. I'm going to go ahead and substitute this into the quadratic formula. So it's going to be -4 plus or minus the square root of 4 squared minus 4 times 1 times 13 all over 2 times 1. And I'm not going to spend the time on the video to simplify this. Every single one of you should be able to simplify that. And so when you do simplify, and if you didn't, we can certainly talk about this in class, but when this is simplified, you're going to get -2 plus or minus 3i. And so when we're talking about the zeros, we would have -2. I'm going to put it in a solution set. So I would have -2. I would have -2 plus 3i and -2 minus 3i. Here's another example. I'm going to go ahead and do this example as well, and then I have one for you to try. So I'm going to find all the zeros. The very first thing I'm going to do is graph it. So go ahead back into y equals, clear the last graph out, and go ahead and type this one in. I am going to unhighlight this and highlight this. And we're going to take a look at the graph in the standard window. So hopefully you're following right along with me here. And so we can see that it actually crosses the x-axis 3 times, and it looks to be at -3, -1, and 5. And so we can go ahead and verify that. Keep in mind, this is turning. Okay, this isn't just 3 separate lines. This is all connected. So if we zoom out, we could certainly see that graph. But I'm going to look at the table for now and just go ahead and verify those 3 values. So at -3, we can see y is 0, -1, y is 0, and then when x is 5, it's also 0. So those are in fact the 3 real zeros, excuse me, but as you can see from the degree is 5, which means we have a total of 5 zeros. So we know that there are 5 zeros, and so far we know 3 of those to be -3, -1, and 5. And so there's 2 more that we have to find using synthetic division. So the way we're going to do it is just take one of the zeros to start, and lucky for us, every single exponent is accounted for, so we can just go ahead and start with synthetic division. So I have -3. I'm going to take every single coefficient. And because this is a 0, we should get 0 as the remainder once we do the synthetic division. That's always going to be the case. So I'm going to bring this one down. Multiply, add, multiply, add, and so on. And so we get a positive 150 here, which gives us a remainder of 0. So at this point, we could write this into another polynomial, but I'm just going to actually keep going with synthetic division. I'm going to take my next root, or my next 0, same thing, and that's -1. And I'm going to go ahead and do synthetic division again. So just keep in mind, this would have been x to the 4th. I guess I'm going to write that as a little reminder. This would have been x to the 4th right here. So I'm going to bring this one down and do the same thing. Nope, that's 1, sorry. You can certainly do a few do-to-dos while you're doing this. It's very helpful. Add those up, we have a remainder of 0, that's what we want. So then this would be, because this was x to the 4th, we would have x cubed right here, and we're going to go ahead and do synthetic division one more time with our last 0, which is 5. Multiply, add, multiply, add, multiply, add. And so this would have been x to the 4th, this would have been x cubed, which means this is going to be the coefficient of x squared. And so our remaining polynomial would be x squared minus 4x plus 10. And again, I'm going to set that equal to 0. And because I know there's no more real zeros, that must mean that the other two zeros are imaginary. So we're going to have to use the quadratic formula again. I'm going to get it started for you, but I'm not going to finish because at this point, everybody should be able to use the quadratic formula. So your A value would be 1, your B value would be -4, and your C value should be 10. And so you're going to go ahead and substitute that into the quadratic formula and then simplify to get your other two zeros. Those would be your imaginary zeros. All right, here's one to try on your own. And that is finally the end of this video. I only went over by just a minute. And so we're going to go ahead and try some other examples in class.